So in the first session, I will call Ivan Kurniawan from Universitas Indonesia. Ivan, are you ready for the presentation now?
Hello everyone. Let me introduce myself. My name is Ivan Kurniawan from University of Indonesia, and today I would like to share one of my research, which entitled System Modeling and Simulation for Study of Human-Machine Collaboration, Technologies Implementation on Assembly Line. And then this is the introduction for my study. Nowadays, Industry 4.0 becomes one of the need for industries while considering primary value-added factors such as quality and efficiency to achieve mass customization. One of the key technology for implementing Industry 4.0 is a human-machine collaboration, or HMC. The purpose of HMC is to enhance the efficiency and productivity of production, and also giving the ability to create flexibility for production changes. This study developed a simulation model for car toys assembly line that will implement collaborative robots into the system. The assembly line used for this study is based on a toy car assembly practicum, which also called Lean Simulator, with the objective to demonstrate various types of lean tools. To ensure that the addition of this technology will provide the expected value add without creating new problems, the research will study the improvements that might be obtained from the addition of this new technology. This study also investigates the effect of sequencing rules that applied to the resources on the system performances. And then there are three main literature reviews that used for this study. The first is simulation modeling, the second is distributed simulation, and the third one is the human-machine collaboration. And then for the methodology, it divided into two parts. The first is about the modeling, and the second is about the results. The modeling consists of assembly process, events module, resources sequencing rules, and development of simulation environment. And for the result, there are performance measurement, which consists of production rate, flow time, and resources utilization, and Pareto frontier analysis. And then this is the assembly process and the event module in order to assemble a car toys. It started for the car toys assembly process. It started with dynamo attachment process, and then continue with the tires assembly process, and then the roller screwing process, and then body assembly process, and then it will be ended by the packaging process. And then table 1 represent the assembly process event module. And then there is an event in here, and then the processing time that used for the event, and then the resources involvement, which is the resource that are used in order to execute the event. And then for the sequencing rules and the simulation environment, so there are two sequencing rules that use for the arm robot, which are FIFO, or first in, first out, and then the task priority. And then for the operator, is also adopting two sequencing rules, which is the first available and shortest route. And then for the figure 2 is displaying the simulation environment. The simulation in here is developed by using a software called FlexSim. And then this is the simulation settings that are used in order to develop the simulation environment. The first is the source input is set with inter-arrival time with the normal distribution of mean 180 seconds and standard deviation of 30 seconds. The time horizon in the simulation is 1 hour, is equal to 3,600 seconds. Two sequencing rules are applied to the arm robot and two sequencing rules are applied to the operators. Therefore, it resulted in 4 sequencing combinations between arm robot and operators. And then each combination conducted 30 times of replication. The simulation will be stopped when reaching the time of 4 hours production time. The performance that measured is arm robot, sequencing robot, and operator utilizations, and then the system throughput per hour and the average flow time. The model verification and model validation is by using input validation. So input validation is a way to validate the model by replicating the real system into the simulation model and observe if the simulation model can represent the behavior, structure, and condition of the actual system. And then the simulation result over here is divided into two main parts. The first is the system performances simulation result, and the second one is the resource utilizations simulation result. Table 3 represents the system performances simulation result. In here, what are measured are throughput per hour and the flow time. And then for the table 4, it's displaying resource utilization simulation result. And then there are 5 resources that measured in here, which are the arm robot 1, arm robot 2, the screen robot, the operator 1, and operator 2. The utilizations in here are measured in percentage. And then this one is the Pareto frontier analysis of throughput per hour versus the flow time. The sequencing combination, the sequence combination of 2 and 2, which are the task priority for arm robot and the shortest route for the operator, can satisfy both system performance objectives. And then, therefore, we can say a sequence combination of 2 and 2 resulted into the best performance. And then, from the comprehensive analysis that has been conducted, the smaller value of flow time resulted in a higher number of hourly throughput. Therefore, the system can be enhanced by decreasing the flow time. Resources sequencing rules resulted in different value of system output performance. Therefore, sequencing rules is one of the methods that able to enhance the system performance without adding new resource and able to utilize the existing resources. Arm robot sequencing rule with the task priority has much less flow time value and higher throughput per hour. Collaborative robot enables flexibility in the assembly line. Various product types can be produced in a single assembly line. Therefore, collaborative robot suits for achieving mass customization, which nowadays become the challenge for manufacturers. Operator sequencing rules produce system performance enhancement. And then this is the last part of my presentation for today, the conclusion and the future study. For the conclusion, this study developed a simulation model of a car toys assembly line, which will implement collaborative robots into the system. The simulation model is a discrete event simulation, or DES, and developed by using FlexSim. The goal of the model is to visualize the predicted system behavior and system performance. Collaborative robot implementation enables product flexibility in the assembly line. Therefore, several product types able to be served in a single assembly line. Simulation model considered one of the approach to obtain system performances. The sequencing rules applied to assembly line resources resulted in performance enhancement, utilization of resources, and product types flexibility. And then the future study that might be conducted for based on my research are the first is more type of sequencing rules for the resources can be used, and then other system performance such as delivery performance also need to be measured. And then the last one is new advanced practical modules might be developed to observe and learn the automation system and the assembly system able to cope the challenges of Industry 4.0, which is mass customization. And then these are the references that I use in my paper. And then this is the end of my presentation. Thank you so much for your attention and your time.
Thank you, Ivan, for the presentation. I hope you can hear and present here. So we can continue with the question and answer. Ivan, are you here? Okay, Ivan.
Hello, everyone. Sorry, I found out there's some troubles in my Zoom. So I would like you guys to welcome if there is any question regarding my presentation.
Okay. Okay. This is the question. Good afternoon. From what I can gather, the ability to make flexible changes on the field. This is the question from Pak J. Hosfat. So the ability to make flexible changes on the field, which was the main advantage of using people in the factory, is now granted to machine as well. Won't this possibly push people out of factory, which will eliminate job which is not desirable for not just the factory, but also the economy? Okay, Ivan?
Okay, thank you for your question. So actually in my research in here, what I'm discussing is about the human-machine collaboration. And then by the name itself, so it should, actually it still include human as part of the production process. Therefore, in my research, we are not making the production system into something that really automated or make the whole production system or the production line, or in my case is the assembly line is automation. However, in my case in here, I try to combine the advantage of using human and the advantage of using robot, because each of them, either it's human and robot, has its own advantage. For instance, like the human for doing some complex job, in my case the assembly, not all the complex job can be done by using the automated robot. Therefore, on the other hand, some job that using robot in here, such as the pick and place, and maybe in my case is the screwing robot. Actually, one of the advantage of using robot is the endurance. And most likely, robot is also more precise. But actually, if when we are executing some job that require complexity, it still requires human in order to execute that kind of task. So you have additional question in here?
So the additional question, so that what we are doing here is taking the flexibility of humans and augmenting it with robots to improve both endurance and efficiency.
Exactly. That's what I'm trying to do, because in the future, what we are facing is about the mass customization. Therefore, flexibility in the assembly line become one of the issue that we're trying to solve the problem, especially about the problem about efficiency and productivity. By creating the human-machine collaboration, the human and the robot might work collaboratively together. Okay, thank you. That's for my answer.
Okay, thank you, Ivan. Is there any question? Okay, Ivan, this is the latest trend in human-machine interaction. Actually, we are today start talking about human-machine cooperation, human-robot cooperation, or human-robot collaboration. In your simulation, did you do something that maybe you measure about the job that cannot be done by the human because of the movement or because of the heavy weight in manual handling, for example, into your consideration when you are doing your simulation here? Or is that the possibility to replace the task that cannot be done by human, and then this replaced by or substitute by the machine or robot?
Yes, I think I can put it as a consideration. Maybe I will put it in as a future study. I haven't put that consideration into my simulation for my case. But one other things that I'm trying to achieve in the future is connect between the physical objects for instance, the robot and the human, or maybe the conveyor in my case, by using real time, and then the real-time data can be used as the input in my simulation. So that's one of the future research that might be conducted in the future as well.
Okay, very interesting. Because I don't see another question here, so thank you, Ivan, for the presentation and the discussion.